continue?
Okay, we can.
Yeah.
Here.
Yes, sure.
Okay, let's continue. Just now, I have introduced about the core network architecture. Next, I will introduce the barrel network architecture. Barrel network architecture. It's about our transport network. On the left side, is a barrel network or transport network for 4G, for LTE, typical like this. Between the aggregation layer and the core layer is the layer 3. This is the layer 3. This is layer 3. Layer 3 means that this node can intercommunicate with each other. Like this equipment can communicate with each other directly. Between the aggregation layer and the access layer is layer 2. This is layer 2. This is layer 2. Layer 2. And layer 2 means that this node, node 1, node 2, node 3, node 4, this node can't communicate directly. They need to communicate through the layer 3. And if this one and if these two nodes, node B, node 1, node 1 and node 2, node 1 and node 2, if they want to communicate, they need to go through the aggregation layer. Go like this. Need to go through the layer 3. And so we call it layer 2. It's something like data link layer. So this is for all the configuration like LTE network like this. Let's see if one mobile has 2 connections like this one. This mobile has 2 connections. If one is for if one mobile has 2 connections, one is for 4G, 4G. This one, sorry, this one, this one. One is 4G, another is 5G, another is 5G. They are having the data stream at the same times, and the 5G is the data angle. So 5G needed to forward his data to 4G. In this case, these two nodes can't communicate directly. If like the NSA, the NR, this base station is the data split. They need to forward the data to the LTE, to the LTE. But these two nodes can't communicate directly. They need to go through the L3 lane to the LTE, So you can say this is an indirect path. This may cause some waste of resource. It may bring more latency. And also, let's say these are 2 5G new radio. This is 5G new radio. Also, if the UE have the multiple connection with the NR, if they want to communicate with each other, they also need to go back to the aggregation layer. You go back to the aggregation layer. go back to aggregation layer. Let's to see these nodes, they can't communicate directly. So the efficiency is lower. And when migrate to 5G, the layer 2 network needed to be upgraded to the layer 3. It means layer 3 to the edge. All base stations can communicate directly. This is our 4G. But for our 5G, for our 5G, and aggregation layer, this is the layer 3. And this layer is also can support the layer 3's function. That's layer 3's function. And the node 1 and the node 2, they can communicate with each other directly. So our data don't need to go through the up layer. Don't go through the go through the aggregation layer. They need they can communicate with each other. So it can reduce the latency. It can serve the bandwidth in IP transmission. And the layer 3's functions new to the edge, and this can enhance the efficiency. This can also facilitate the deployment of user play UPF. So this is our transport network compared with our 4G. They can communicate directly. So the data don't go through the up layer. So it can reduce the delay. They can serve the transmission resource. This is the transport. For transport, please.
Actually, on the both diagram, those dark blue, I mean the circles, are representing the routers. Yes.
Blue.
The circles, those circles. Is it routers?
Yeah. Blue color. This one.
Yeah. No. The down.
This
the
one.
Circle. Yeah. No. I mean, the dark blue. The circles. Yes. This one.
Circle. Yeah.
Yes. Is it the routers? Yes.
Yeah.
It's right. Okay. So, for example, when you need to connect two network and more, we have to use some kind of routing protocol. So, do you know which kind of routing protocol have been used in those architecture? For example, we have a dynamic routing protocol and static routing protocol. For example, nowadays OSPF is one of the most common and important routing protocol in the world for internet connection. So do you know which kind of routing protocol has been used in this for 5G architecture, for example?
Sorry, this is IP's knowledge. I'm not very clear. This is for networking, network technology. Sorry, I'm not very clearly. But after class, I asked my colleague let's measure in the IP transmission. Okay.
Thank you.
You mean
yes.
This,
for example, if we need to make connection between those two routers, for example. Yes, we have to use the routing protocol. So we have two kinds of routing protocol, dynamic and static. So mainly it will be the dynamic, but in dynamic we have lots of different type of routing protocol. It might be important for us to know, which kind of routing protocol has been used in in those kind of architecture. Thank you very much.
Okay. I ask my colleague teach route and switch. Let me know which protocol be used in
protocol. Yes.
Protocol be used in here. Okay.
Thank you very much. Thanks.
Okay. This is next we will start the Flexi. Flexi can realize the network slice. Flexi actually Flexi is not the new technology. Actually, it's used in 2G, 3G. In 2G, 3G based on the TDM. Like S1, T1, like the transmission used in 2G and 3G. But now in our 5G, we also use this technology. And we can see here are some different service, like we are cloud VPN, like V2X, like a mobile data service, like IoT, these are different service. These different service need a different slice of network, the network slice. There can be radio slicing, transport networking slicing, and core network slice. For the radio network slicing, we can just slice different carriers. And for the core network slicing, we can combine different function. How about the transport networking slicing? We have said use the Flexi. For this transport, we can separate the resource into different time slots. For example, slice A give it one slot. Slice 2 give it 2 slots. And the slice C also give it one slot. How many slots needed is just depend on the requirement of bandwidth. So like this, we have 3 type slice: EMBB, and URLC, EMBB, URLC, and MMTC, using different time slots for hot pipe. So in this case, we have 3 slices. In each slice, there can be logical ID. You can say logical ID for different user. Service ID for a different user. So this is how to do slicing in transport network. Each of slicing will act as an independent subnetwork. So I said the slicing can guarantee the bandwidth, can guarantee the URL latency. So it's hard. Flexi is based on the TDM. Has a hard separation. And they have each of slicing will act as an independent subnetwork. For example, if the slice A didn't use, let's say slice A can't shared to the other slice. So it's just the slice A, just the list transmission resource, just for the service ID 1. Can't use the service ID 2. We call it Flexi. It's hard pipe. They have the independent control plane. Control plane is the service management, and also data plane and user plane for the data transfer. And as if each slice is just one division network. Actually, it's one physical network, and logically, it can be multiple networks. So why we say that? 5G can meet to guarantee the users' experience in transport. We use the Flexi to make sure the user have a guaranteed data rate. Yeah, this is Flexi. And the wireless and the wireless cloud RAN evolution. And then for wireless network, we also have the architecture evolution. DRAN, CRAN, and Cloud RAN. D means distributed RAN, and CRAN means the centralized. And Cloud RAN means Cloud RAN. DRAN, we know DRAN. Actually, in our 4G network, we use the DRAN, distributed RAN, or BBU plus RU, and will be deployed in the city. One base station, and for the coverage. And nowadays, all the commercial network use DRAN. And the CRAN means that BBU are installed in the center equipment. BBU centralized deployment. This advantage that can improve the baseband coordination. Can utilize the BBU's baseband resource. And lot of BBU installed together. They can share their resource. They can have the coordination of the baseband resource. It's good for the resource sharing. But it need more optical fiber. It need more optical fiber. Actually, in our railway, highway, maybe we use this mode, centralized RAN in equipment. Maybe it is equipment, and there are multiple BBU in the equipment room, and there are many base station near the railway. And through the optical fiber. This mode, it may need a lot of optical fiber for the connection. For base station, only their radio unit only have RU or AAU, so they need optical fiber connection. So this is why good for the baseband coordination, but it need more optical fiber. Here we can see for the DRAN and the CRAN, we have one BBU. We have one BBU. Actually, another is the Cloud RAN. This BBU is separated in CU and DU. CU may called central unit, and the DU called distributed unit. So for the processing, which need low latency, real-time processing will be in the DU at the base station side. And for the processing, which is not real-time processing, usually just the control plane process and will be deployed in the CU, control plane, control signaling. So we can say DU is a simplified BBU, simplified BBU. You can see this structure looks like our 2G and 3G, like the RNC, like BTS, 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 or BSC, BSC, BTS, like or 2G and 3G. So the CU, you can CU often deploy the control plane signaling, and the DU because the DU can near the user, they may they can process the real time processing, real time or the low latencies requirement. You can see this is the future. This is the future of structure. This is our 5G's cloud RAN, maybe used in the future. Actually, it also depend on the slice or the deployment song, different service. And the CU, DU deploy solution. About the CU deployment, CU can be deployed in the cloudified CU, cloudified, and can be deployed in center DC, and it can manage the more resource. It can manage multiple DU. They can manage more DU. But the shortcoming is that the delay is longer because the distance is longer. Delay is longer. The DU can also be deployed at the aggregation layer. The CU. The CU also can deploy on the aggregation layer. In this case, it will be near the DU. Delay will be shorter because the distance is shorter. The shortcoming is that the CU can manage less the DU. Can manage less the DU, less number of the DU, because it is near the base station and can be connected with less number of base station. This one can manage along the 100 times of the DU, and this one just can manage around 10 times of the DU. This also both mode have his advantage and disadvantage. Depend on your need. Okay, this is CU and the DU. Okay, have any question? About core network architecture, bare network architecture, and wireless network architecture. Have any question?
Yes, please. Hello.
Okay. Next. Have any question?
Yes, if you mind. You hear me?
Yes, please.
Can you back for the last? Yes. You see for each option, there is some advantages of course, more than the other options. So the change from one option to another option is maybe there is many connections between central unit and aggregation layer and site. So change from one option to another is difficult or need some upgrading or because there is some point-to-point access and maybe wired cabling between different sectors, but the changing from one option to another is need the modification or automation is or simple. Thank you.
Sorry, what's your point? Your question is the difference between option 1 and the option 2, and or the disadvantage or advantage?
No. My question is when we need to change from one option to another.
Yeah.
You need many connections between central clouding or aggregation layer or site layer. Is this changing is difficult or simple? Because this is connected point-to-point access or connections, maybe wiring fiber optic through the fiber optic connections. This changing is easy for operator, or just need time, or just automation is not so difficult, or just software can be changed so they smoothly change from one option to another?
Oh, okay. You mean if we want to change option 1 to option 2, is it easy or not? Is your question?
Yes.
Okay. Actually, in my opinion, for this mode, option 1, CU can manage the multiple DU. It needs a large optical fiber. But for CU, in some scenarios, the low latency, we need option 2. You mean option 1 change option 2? Is it easy or not? In my opinion, and I think it's simple. Just is networking. If you have this need, I think just change the network architecture. I think there's no difficult in my opinion. Yeah. Clearly, or is not your opinion or point?
Thank you very much.
Okay. Next, we will learn some about the new interface technology. I think this is also very important for us to understand why 5G can achieve the high throughput, achieve the low latency, and so on. And for the new air interface, we introduced a lot of new technologies like large bandwidth. In our LT network, just can support 1.4, 5, and 10, and 15, and 20 megahertz. This is our 4G. 4G. But for our 5G, we can support many. We can support like 100 megahertz in 6 gigahertz, even 400 megahertz in our millimeter wave. In millimeter wave. So this is one reason why our 5G can realized the 10 gig bps, 10 gig bps rate. And the second is a high level adjustment, high level modulation. This to provide more bandwidth. Like we can support 1024 QAM. Can improve the throughput. And then the massive MIMO. Massive MIMO is provide the better coverage and also better capacity. Massive MIMO. Massive MIMO is also one of the key technology about the 5G. And another is Polo code and LDPC code. Also provide us more efficiency in control play and in user play. And the FDM, OFDM, F means the filter, OFDM, also have the high efficiency compared with the our 4G's OFDM. And the flexible frame structure. Flexible, it can provide more spectral efficiency. And then uplink and downlink decoupling provide a better uplink coverage. And we will introduce these techniques one by one. And with these techniques, technology introduced, it can satisfy more requirement for different service. For example, some for broadened bandwidth for mobile internet, eMBB. Some may provide more numbers of connections or less latencies, like the IoT. Let's start the first one. Large bandwidth. We can see here the 5G frequency band ranging have two free range. One is free range 1 and free range 2. And the popular bandwidth is 3.5. 3.5 is used widely in the world. And this is FR1. Below sub 6G, mainly on 3.5 GHz. And also this frequency band also can be used if our 2G and 3G network stopped. And the frequency band also can be used. And another is the FR2. FR2 is a millimeter wave, and used widely is 28 gigahertz. 28 gigahertz at millimeter wave. It also is widely used in FWA, physics wireless access. Especially in some Europe country, they don't want digital hall in their city, so they often use FWA for the signal coverage. It's very easy. And our millimeter wave frequency band is also very is a available resource. There are much available resource in millimeter wave. Maybe in the 6G also use this millimeter wave. And for large bandwidth.
Excuse me. Please. In this figure about this frequency division, is it possible in the same network to use both frequency? I mean, in the same frequency network, it is possible to use sub 30 gigahertz, sub 3 gigahertz and 28 gigahertz.
Yes, okay. This millimeter wave high frequency band used for supplementary in the shopping mall, in the hotspot. They can use the at the same time. No problem. No problem.
Okay, thanks.
Yeah, the low frequency band. And our 4G and 3G. Our 4G use 1.8. Our 4G or 5G use 3.5. Because of the different frequency band, so it doesn't matter. No interference. Yeah. They can at the same time they can simultaneously provide the service to the terminal. And this band large bandwidth, those spectral range are used by carrier. This is our 4G, and this is our 5G. 5G support so many bandwidths, 5, 10, 15. If one day LTE didn't use 4G's frequency band, 4G didn't use and its frequency bands also can be used in 5G. You also use the 5G. And FR2 Maximal can support 400 megahertz. So in this mode, it can support 10 gig BPS. Support 10 Gbps, 10 Gbps. And the spectrum this is about our large spectrum, large bandwidth, mostly in the early stage, we use this one. 100 megahertz, this bandwidth. And discussion of China's Unicom. This is one of the China's operator 5G target network spectrum. In our 5G, the network frequency band is high. Its bandwidth is also very large, and it often used in the sitting center, used in the shopping mall or cinema or gyms. And our 4G is MBB capacity layer, use the low frequency band like the 1.8 and 2.1. Use this one, and for the coverage, for far coverage, and use the low frequency band for the further coverage, further coverage. So our operator have 2G network, 3G network, and 4G network, and even 5G network. All modes, all this mode network can provide a service the network signals to the user. So the low frequency band has a good coverage, so it used in the various suburban area, and in the dense urban areas, we can use the high frequency band, use our 5G, and also these areas has much people have have much traffic, has much traffic. Yeah, and And this large bandwidth, C-band coverage performance, you know, this color is downlink, this uplink, for our uplink, for our downlink, the coverage is better than uplink. You know, for downlink, I just can cover the 715 meter uplink. Sorry. For downlink, just can support 715 kilometer, but for uplink it can just support 300 meter. So it's not imbalances. We can say uplink 10 gigahertz, downlink 10 gigahertz. Uplink just have 1 Mbps and 15 Mbps. Uplink just have 5. So it's imbalances. How to solve this issue? Huawei has announced the uplink and the downlink decouplling. What's the decouplling? We can also call it SUL. It means supplementary uplink. It is used to enhance uplink signal. Look at this picture. You know the yellow color is coverage for the uplink for C-band, and the green color is the coverage for downlink C-band, And when the UE near the base station, the signal is very good. So the uplink and the downlink, the service, the signal quality is good. It doesn't matter. But if the UE are far away, the base station, for downlink, the signal is no problem because the base station can enhance the power, improve the power for the coverage for the UE. The UE can have a good signal quality. But if the uplink, the UE's power is limited. But if the UE far away from the base station, the signal may be weak. With the gap. The gap is 13.7 dB. So it's imbalances. And how to solve this issue? We use SUL. When the UE far away the base station, and the UE may use the 4G's frequency band. Use this frequency 1.8 gigahertz. Low frequency band has a good coverage. So to make sure the uplink can also have a good signal quality, we use this low frequency band to solve this imbalances issues. So we call it uplink and downlink decoupling. This is the standard announced by the Huawei company. Okay, have any question about this part?
Excuse me.
Please.
Yeah, in the right figure, you mean there should be used two types of antenna, right?
Maybe in the future, the one antenna can support 4G, 5G.
The same antenna or also different antennas?
Can be different antennas, and some antennas can be used in 4G, used for 4G and 5G. Can be used in different frequency.
Okay.
Yeah.
Thanks.
And the antenna, maybe in the now the antenna are more integrated, can be used for 4G, 5G. One antenna is okay. It can support multiple frequency band. Yeah.
Or reconfigurable antennas. Maybe reconfigurable antennas. Maybe we can use to solve this problem.
Yeah.
Okay. Thanks.
Okay, left several minutes, and I think we can discuss.
Please, one question.
Please.
Actually, there's my request is, can you provide us with some details information about wireless technology? You know, the most important ones is how we can just use 124 quadrature amplitude modulation. So this is how will be the curve of signal to noise with the signal to noise ratio and details. You know, also about massive MIMO. There is different types of MIMO system, and which one is most useful in 5G. In the same time, filtered OFDM. You know, orthogonal frequency division multiplexing systems used in both for 4G in uplink and downlink. Single carrier OFDM used in uplink and OFDM used in 4G. But what's the difference between filtered OFDM? Just about the sharpening the filters used, or details about these kinds of technologies in wireless? Thank you.
Why your question is about the 5G security?
Just if you provide some details about the wireless technologies in 5G, for example, about the 124 QAM, how would be the curve of SNR and technologies available with this technique? In the same time, massive MIMO, there's different types of MIMO. Which one is preferred in 5G? In the same time, the OFDM. What is the main difference between filtered OFDM and what that's used in 4G, for example, signal carrier OFDM or OFDM in the downlink? Some details, information about wireless technologies in 5G, not just maybe in this what we see in the pictures is clear, but need some details.
I know. Actually, in these materials, there are some introduction about the air interface of some key technology. But you know, this course is focused on IA, HCIA. This course means is a basic technology about the 5G, and about the air interface, like the wireless security and some air interface technology will be introduced in HCIP. In this course, we will introduce in detail But for HCIA, we may just introduce the basic technology about like security, like the scheduling, and like the channel and so on. Just because it's HCIA basic technology. Okay.
Thank you.
Okay. Have any question?